Okay, on to Chapter 4. Chapter 4 gets us into fractions, decimals, and percents. So really what we're doing is you're going to see a lot of what you saw in the first couple of chapters here in handling values that are fractions, decimals, and later turned into percentages. So we've got about 11 sections in the textbook. The first thing we're going to do is look at what constitutes a prime number or a prime factor and reducing numbers to the lowest terms. We're going to need this when we're doing addition or subtraction using fractions. Multiplication of fractions, division of fractions, computing that lowest common multiple. Again, more adding, subtracting, multiplication and division, this time with improper fractions. What's an improper fraction? 5/4. 5/4 is an improper fraction. Why? Well, because it's more than 4/4. 4/4 is 1, so it means you've got what? One more fourth left over. So an improper fraction is just a number that in a scheme that you wouldn't normally use. You know, for those of you that cook or bake, you know, you're never going to see an instruction that says add 5/4 cup of flour. I'm like, no, it's going to say use 1.25 cups, right? So we have to deal with how do we handle improper fractions. And then multiplying, division, addition, and subtraction. And then we're going to look at doing percentages. So in the objectives, we're going to look at identifying prime numbers, finding lowest common multiples, dividing, multiplying, adding, and subtracting with common denominators and unlike denominators, expressing numbers as either mixed numbers or improper fractions, dealing with them, and then doing some conversions. So first off, prime numbers and prime factors. When two or more whole numbers are multiplied together, the result is called the product of those two numbers. So whenever we multiply, we get a product. Whenever we divide, we get a quotient. Whenever we add, we get a sum. Whenever we subtract, we get a difference. So get used to hearing these terms. Two or more original numbers are called the factors of the product, okay? If we look at the example, 3 times 7 is 21. 3 and 7 are the original numbers. They are prime, and they are factors of 21. A number that has no multiple or has no whole number factors except one. I got all kinds of errors in here. Except, fat fingers, except one, it and itself is called a prime number. So prime numbers, you know, you probably went through the drill when you were in middle school or in the 8th grade of factoring and doing prime numbers. Identify all the prime numbers between, 1 and 100, and you had to go through, and your teacher made you identify these 2, 3, 5, 7, 11, blah, 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 13, on the way, all the way up the line until you got to 100. And it was just to give you an idea of numbers that could not be factored down. They are as small as they can get. A number that is not prime is divisible by more than one prime number. So what are the non-primes? 2, 4, 6, 9, 10. Why? Because I can divide 2 into 4. I can divide 2 and 3 into 6. I can divide 2 and 2 and 2 into 8. I can divide 3 and 3 into 9. I can divide 2 and 5 into 10. So they are not considered prime numbers because they can be factored down to a prime number. Prime numbers that make up a non-prime number are called prime factors then. Prime numbers then, looking at them as prime factors, well, we just kind of discussed that, but 10, 2 times 5. 2 and 5 are both prime. 15, 3 times 5. 3 and 5 are both prime. 21, 3 and 7 are both prime. 26, 2 and 13 are both prime. So all of the numbers on the left-hand side, not prime. All of the values or terms on the right-hand side, all prime. Okay, so non-prime, prime. So if we look at then 8, well, 8 has what? 3 2's in it. 2 times 2 times 2. Because if I factor 2 into it, I get 4, and then I can do that one more time, and I get 2 times 2. So it gives me 2 cubed. This is handy. This is a value that we're going to encounter over and over again. These cubed values. Cubed, 3 cubed. 2 squared and 3 squared are the factors of 36. 2 and 3 and 5 squared are the factors of 150. All of these on the left side can be factored down. Everything else on the right side are considered prime values. So looking at then fractions and using these prime values to get values down to their lowest terms, fractions have been reduced to lowest terms when there are no common factors left in the numerator and the denominator. To reduce fractions to lowest terms, we first find the factors that are in both the numerator and the denominator, and we start canceling them out. If we have the same number in the numerator and the denominator, cancel it. It's 1, right? 2 over 2 is 1. 3 over 3 is 1. 2 times 2 over 2 times 2 is 1. So 4 over 5 is 2 times 2 times 5. No common factors. It's done. 4 over 5 is as small as we can get. 11 over 130. 11 is prime. 130 we can factor by 2, by 5, by 13. Nothing common in the numerator and the denominator. We're done. 12 over 21. Different story. 12 is 2 times 2 times 3, right? 4 times 3 is 12. And the denominator, 3 times 7. Well, look at here. We got a 3 in the denominator. We got a 3 in the numerator. That's 1. 3 over 3 is 1. Cancel them out. So what are we left with? 2 times 2, which is 4, divided by 7. Often with experience, we can quickly then recognize common factors that can be canceled. We call this, again, doing it by inspection. By inspection, we've got 2 zeros, a 0 in the numerator, a 0 in the denominator. All that means is we're multiplying times 100. Get rid of them. So we can cancel those out. What are we left with? 14 over 15. 14 is 2 times 7. 15 is 3 times 5. We're done. 14 over 15 is 14 fifteenths is prime. No, it can't be factored any lower. Okay? Or does not have a common factor. 105 over 130. Okay? I think I've got this one wrong. This should probably be 135. We could cancel out the 5s. So I'll have to look in the textbook on that. Verify that for me, okay? Just going to humor you here and say, let's say that was, in fact, 5. Then we have, I'm going to try to correct this on the fly here. Then we've got a 5 and a 5, common factors in the numerator and the denominator, and we will end up canceling them out. Okay, so I'm going to have to go back and look on this one, make sure I haven't transposed this. 21 over 27, dividing both the numerator and the denominator by 5, we end up with 7/9. That's reduced to the lowest terms. Okay. Another rule, 4-1. To multiply fractions, we 1. Cancel factors that are in both the numerator and the denominator. 2. Multiply the remaining numerators. Their product is the numerator of the answer. Finally, 3. Multiply the remaining denominators. Their product is the denominator of the answer. So let's look at a problem. 2/3 times 4/5. 2/3 times 4/5 is 2 times 4, 3 times 5. So that gives us 8 over 15. Can't take that down any lower. 3/4 times 2/3 times 5/6. So that's 3 times 2 times 5, which gives us a 5 in the numerator. 2 times 2 times 2 times 3 times 3 when we factor out 4 and 3 and 6. So what have we got? We've got a pair of 3's, numerator and denominator, a pair of 2's. So those cancel out, and I'm left with a 5 in the numerator, 2 and 2, which is 4, and 3, which gives me 12. So 5/12 is the value of these all multiplied together as its lowest terms. In division of fractions, a little different. We invert and multiply, okay? So now we have 1/5, we're dividing by 1/3. If we invert the second term, which ends up being the denominator, we have 1/5 times 3. So now we have 3/5. We're done. How about 3/8 divided by 3/4? We invert 3/4 to 4/3 and multiply. Well, here, 3 and 3 cancel out. I'm left with 4/8. I know that 4 is 2 times 2, and that there is a 4 times 2 in the denominator. I'm left with 1/2. So you can see a lot of times you can look at these. Once you practice them, you can do them by inspection, and you'll be down to the lowest factors pretty quickly. Addition and subtraction of fractions. 2 or more fractions can be combined into one when the denominators are identical. You got to have that denominator with the same value, or you cannot add it together. So can I add 1/5 and 2/5 together? Yes, because the denominators are the same. So since they're the same, I have 1/5, and then I have 1 plus 2, which gives me 3. 3/5 is 1/5 and 2/5. Okay, again, you can look at that by inspection and go, well, hell, if I add another 1/5 to 2/5, I know I've got 3/5. Okay, 4/11 added to 3/11 added to 2/11. Okay, I can very quickly look at that and say, okay, they all have 11 in the denominator. What do I have in the numerator? 4, 7, 9. So 9/11. Boom, you're done. I mean, you can look at these things fairly quickly and do it by inspection. Subtraction, if we consider fractions where part or all of the fraction is negative, then we have to deal with some signs. There are 3 signs associated with any fraction: the sign of the numerator, the sign of the denominator, and then the sign of the entire fraction. So this one gets a little tricky because you have to keep track of the signs so that when you're done, you have the correct polarity, if you will. So if I have minus 3/8 and I assume that I've got a plus sign out here, I can move that negative out of the numerator and I end up with minus 3/8 for the entire fraction. Okay? Do the same thing, moving the negative out of the denominator. Again, I get minus 3/8. So I can very quickly move that negative sign out of the numerator and the denominator, and it becomes the sign of the entire fraction. That is very helpful sometimes. Okay, so if we look at performing an operation, 7/8 minus 3/8, you can see that as we move the signs around, we're going to add them, but we're going to move that sign into the numerator so that with the common denominator of 8, 7 minus 3 gives us 4/8. I know I can reduce 4/8 down to 1/2 because 4 goes into 8 2 times. Okay, do the same thing with the second example. Okay, so when we come back, we're going to look at the lowest common multiple.